Hello and welcome to this special USB rubber ducky segment. I'm your host, Darren Kitchen of Hack5, and we're talking about, well, the USB rubber ducky. This is, of course, the hardware that has been on our minds for a couple of years now and finally come out in a wonderful package. I couldn't be happier with this because it is so powerful and so versatile. And what I'd like to do today is walk you through some of the basic features. Of course, this is being recorded September 28th, 2011, so we're using the 1.0 version of the firmware and of the Duck encoder. And what I'd like to do is just go ahead and give you guys what I'd consider a quack start guide. Paul's shaking his head. Okay, well, let's go ahead and get started. As you guys know, the Duck is an evil HID. It's a human interface device. It can mimic a keyboard. It can do so much more, but that is the basic payload that we're focusing on today. There are other possibilities of COM ports and other USB devices that it can emulate. But for right now, we're just going to go ahead and focus on that. But that is why we're very excited about this, the versatility. And what I'd like to show you is how you can quickly get started writing some payloads and getting familiar with it. So, first of all, usbrubberducky.com. This is the wiki. This is where you can find all of the information on the hardware, the latest software, where to post your payloads, find more payloads, share snippets of code in our forums, as well as other tutorials and things of that nature. So I will direct you over to the hardware. If you're not familiar, this right here is a Amtel, or I'm sorry, an Atmel 32-bit AVR. It's a 60 megahertz chip that is 32-bit, so quite a lot of power there. And we have a little bit of JTAG and I/O to go along with the push button, which we can use for, in its current state, reactivating or re-executing the script, as well as a LED for an indicator. And this is all packaged on a board with a micro SD slot, which we can use for our payloads, and of course a standard USB Type A connector. Basic operation is quite simple. You put a file on the root of the micro SD card named inject.bin. And with the current firmware, what happens is as soon as you plug in the USB rubber ducky to a machine, it starts executing that. And now that bin file is created with our Duck encoder. And that is what compiles the text file scripts, the human readable, simple, basic English that you write in Notepad or gedit or TextEdit or whatever have you. And then it compiles it into that bin so that it'll execute as a keyboard. Now, my setup here is pretty basic. What I'm going to be using here to show you some of the basic features is a Windows 7 laptop. This is fully patched. It has UAC enabled. It's what you would expect to find in the field, as well as my Ubuntu 10.04 box. And we just have that on the display here, and then I'm screen recording here so you guys can see what's going on in the terminal. Of course, you could use, since the Duck encoder is Java, you could use this on a Mac, on Windows, on a Linux, Solaris, whatever have you. If it will run Java, you can use it to start programming for the Ducky. Really, we're just talking about ASCII files here, and that's one of the beautiful things. That's why this is one of the reasons why it took so long to develop, is because we wanted something as simple and straightforward as the USB Switchblade, where you could write payloads in batch files. So, so let's go ahead and get started with the Duck encoder and write, I don't know, aptly a hello world. So I'm pulling up my prompt here, and I'm going to go ahead over to media, and I have a device here with the version 1 code. And there it is, the duck encode.jar. So let's go ahead and do java tac-jar duck encode.jar, just straight how it is. All right, and what we're going to get here is a little bit of information on how to use the Duck encoder 1.0. The usage is that you give it tac-I in the file, or tac-I in the file and tac-O and the bin file that you want to create. If you don't give it the tac-O, it's just going to create an inject.bin in the path that you're currently in your current working directory. If you give it a tac-O, you can specify where you want that inject.bin to reside. The tac-I is just the input file. That is the text file. And then what we get are these script commands. Now these are just basically the keys on the keyboard, the key combos that you can set up, and this is what we consider the Ducky scripting language. Now, all of that is laid out in the Ducky script page. Over at the wiki, we've got a basic highlight of the syntax. It's pretty similar if you've done any other basic programming, things like rem for comments. The delay command does just that. It's like a pause. It doesn't require any intervention. It just delays for however many milliseconds you specify. There's a default delay, which you can use at the very top of any script to say, I want between every command this amount of delay, which is good for debugging, good for if you're targeting some older machines where you know that you're going to have to put a lot of delays in. There's the string command, which allows you to go ahead and put in a big string of text, or even just a single character. That's how you type a single key, or hello world, and it will go ahead and process those and automatically do the uppercase, lowercase shifting. We also have key combos like GUI or Windows key, the Shift key, the Control key, the Alt key, as well as all of the others, the arrows, the pause break, caps lock, which is cruise control for cool, tab space, you name it, it's all here in the wiki. So let's go ahead and with that knowledge put together our first hello world. So I'm just going to use gedit for our very first one. And so let's, first I'm going to create the file. So I'm going to touch hello world.txt and gedit hello world, and you could have done that a million different ways, just the way I'm going to do it. So we've got our text editor open, we're ready to go. I'm going to start with our first command, rem, a comment command, and you'll notice that all of the commands are in all capital letters, and that's important, so go ahead and do that. It's very old school. You don't have to number it 10, 20, 30 like a basic program or anything, but I like to start off every script with a rem that says, a little bit about what it is. I'm going to say author, Darren Kitchen, and description, hello world. Fair enough. Okay, all this payload is going to do is type out hello world. So what we use is the string command, hello, capital H, and world, capital W, something like that. And let's also have it do a carriage return afterwards, not \n, it's nothing fancy like that. It's really everything's on a new line by itself, capital Enter, because that is the key. And now if I save that file, save, wonderful. I'm going to go ahead and close that. And if I ls there, I see my hello world.txt file. I can less, or I can cat hello world, and there we go. I see it right there, plain as day. Now we need to move it to the duck. So what I'll do here is, this is my own personal one. You'll notice that I've marked it with a little bit of Sharpie. But what I want to do is just pop out the micro SD card. And I'm going to place that in my reader and into my computer. And for me, on Ubuntu, it's just going to show up in /media. So I'll ls/media. And there it is. I can see that the volume name for me is 0007 some other stuff. Not that interesting. So what I want to do is just move that, or use the duck encoder to convert that hello world.txt into an inject.bin on the root of this SD card. So what I'll do is Java, tac jar, duck encoder, tac I for the input file, which is hello world, tac O for the output file, and in this case, I'm just going to go directly there so I don't have to move anything later. Media, 0x whatever, inject.bin. And there we go. Process as simple as that. Now, I have noticed, on my system at least, it really likes me to eject it properly. Quick and easy command is eject, and then whatever the device is. There's a, I think on Windows, it's like right-click on the device and eject from my computer. And then I pull that out, and now it's ready to go right back in the duck. All right, with the case closed, I'll wake up my computer here. So on my Windows 7 box, I'll go ahead and start by opening up Notepad. Oh, Old Faithful. All right, so with Notepad open, it's really just a matter of plugging in the duck. And it types hello world. There we go. Our very first program. All right, so let's jump way ahead and actually start doing some advanced payloads, because this is where the fun stuff comes in. I'm going to close this. I'm not saving. Hooray. So SD card, back out, and into my reader and back into the computer to have some more fun. Now, speaking of fun, there is a lot of fun going on the wiki and in the forums. This is where you can share your payloads, find some payloads right now. One of the payloads I'm interested in is a little prank that we've showed off on Hack 5 that's a fun way to mess with your mates and disable their desktop icons, but then have a wallpaper of when their desktop icons used to be there. And I mean, we've all done this trick, but why not automate it? Why not have it be on a USB Ducky so you can just plug it into somebody's machine, wait a few seconds, unplug it, and it's good to go. The idea here is hopefully through this script we'll very familiarize you with most of the commands, and then we can move on to doing some more fun exploit stuff like compiling some executables and doing some reverse shells. So I have it plugged in, and we will go ahead and head over to the wiki and the payload section. And here we go. Already I see first one, wallpaper prank, and I'm just going to select all of this and copy it. Okay. And this time we're going to create a new file, hackwallpaper.txt, and I'm just going to use nano this time instead of gedit just to show nano some love. I'm going to go ahead and paste that. And let's begin with the top and start walking our way through this. GUI GUI or Windows is the super key or the Windows key. It's been there since 103 keyboards became the standard instead of 101. After that, we're going to delay for 500 milliseconds. Some of these payloads, of course, were delaying for a lot of milliseconds, way longer than we typically would, but considering we're just testing, this is one of those things where it's kind of trial and error, and I always like to err on the side of caution and put way more time in there, because then when I run it on my test machine, I kind of have an idea of where to tweak my delays. So right after that, the print screen button. Any Windows user will know that that is the button to start creating a screenshot. Just print screen alone instead of Shift or Alt or Control is going to do the entire desktop and then copy it to the clipboard. So after that, we delay for 100 milliseconds and we hit the menu key. So if we actually come back over here and follow these steps along on our Windows machine, Windows D, obviously nothing up. Here, we'll open something. And then Windows D goes to the desktop. And then we did the print screen, and if we hit the menu button, you'll see that that pulls up our little context menu. We're delaying 300 milliseconds. And then we do string capital V, and then delay for 40 milliseconds, capital D, which disables our desktop. So I'll go ahead and, or our desktop icons. So I'll put those back on. There we go. And then GUI R. This is a wonderful key combo. Brings up the run menu, of course. And then we're going to delay and then run MS Paint. Delay again after Enter. Control V or CTRL V, either one works. Go ahead and paste that. We're going to delay again. Control S, the save command. Delay here. And then here's where we're actually in the save dialog. So what we'll want to do is give it a path that, and say this person isn't running as administrator or anything, we're going to have to save it in a directory that they can actually access. If we tried to save this in like C:\\, it'd throw up a bunch of warnings. Not something we want to deal with. So in this case, the shortcut %, user profile %, we'll go ahead and put it in C:\users, / whatever their name is, somewhere that they can write to. I'm just calling mine a.bmp. It could be anything. Hit enter. And then after that, here's the combo. Alt F, delay for a second, and then the string K, and then F. We'll go ahead and set that as the desktop wallpaper. Alt F4, of course, is the IRC key combo to get you ops or to close a window. And after that, we delay and GUI D again, which is just bringing us back to our desktop. Pretty simple payload. So we will save those changes, hackwall.txt. And again, just like before, Java, tac jar, duck encode, tac I, hackwall, tac O, and /media, and for me, and then I can just overwrite my inject.bin, and then eject the media. All right. Back into the duck it goes. So now let's actually run this on our Windows 7 target here. So, and we'll have something open just to simulate, we're at somebody's desk, they got some work going, they went to go get a coffee, and we've got like just a few seconds free, but we could totally own them. Let's get rid of those desktop icons and replace it with an awesome wallpaper. Here we go. Plug it in. Immediately installing the driver software, as you can see in the bottom right here, only takes it a second, and it's generic, so it will just go ahead and install on any Windows system, which is beautiful. And it's minimized to the desktop. We've gotten rid of the icons when we're pulling up MS Paint. All right, pasting our wallpaper. Again, saving as a.bmp, and then key combo to set it on the wallpaper. Close this, back to the desktop. And of course, as my user, I'm sitting there going, why won't my file open? All right, that was a fun one. Let's do something a little bit more black hat. Let's start executing code, because that's where a lot of the power of this comes in. The USB Switchblade was a wonderful tool, still is, not as useful on machines like Windows 7 because they don't execute autorun.inf. And the idea here is, while you could do the mass storage component of the Ducky with firmware, I like the idea of simply typing in your executables, because then you're not in some situations you're going to find that there are profiles set up that will not allow storage media to be mounted. So this way we don't actually need to mount any storage media because we can create an executable on the fly. Let me show you how right here. It's in the payload section, again on the wiki, and this one, reverse shell. You know, I need to make a note here. I put author Darren Kitchen, but I need to edit this, and by the time this airs it will, because all of the props go to ill will, because he's set up a wonderful Visual Basic script which converts base 64 encoded ASCII to binary, and that is the magic that is going to make this all work. So let's go through this payload. All right, micro SD card going back in the computer, and let's go through the payload. So again, I'm going to use Nano. Let's use Vi this time. Give Vi some love. And I think I already have this one on my system, admin.txt. There we go. This is the payload. First character, escape, just to make sure if anything was loaded, we hit the escape key, not dealing with that. Then the key combo control escape on a Windows system brings up our start menu. I'm going to delay for a bit and type in the string CMD. I'm going to follow along here. So I have my command opened up, Windows 7, right? And I want to run this as an administrator because we're going to need those privileges to create the files that we're doing right here. We could put these perhaps in the user profile directory and get away with it. But this is a good demonstration of bypassing UAC, how simple it is when you are the keyboard. You're trusted because you're the human, aren't you? Or are you, Quacker? He's like, quack. Yeah? No? Not so much. Okay. Well, we type in CMD, and then we'll want to hit the menu key, or sometimes called the app key, and that is pulling up our context menu. And you can see whenever you pull up these context menus, you're going to see a little underline on different letters for the different options. Not all of them, but most of them, and the ones that are really important. So for instance, run as administrator here has a underscore on the A, so we press A, and then UAC comes in and says, hey, what are you doing? And that's when we simply hit left arrow key and then enter. How is that, Microsoft? All right, so we delay 400, and it's time to use some DOS commands. I know, I'm getting really excited. CopyCon. And remember, we're running as administrator, so we could hide this anywhere. Right now it's in System 32, but we could put it in drivers, we could put wherever, we could name it services.exe. However you want to go about this. I'm just going to put it in the root of the C drive. But copy space con actually on a Windows system, in fact, since DOS like 3, probably before, allows you to copy from the console. So anything we type into the console will be copied into that file. Really nifty tool, C:\\, and we're going to call this decoder.vbs. All right, and now whatever we type into here, I can type all that and hit Control-Z and hit enter, and the file is saved. So that's exactly what we're going to do with our payload. You can see this one string command is putting in all of this Visual Basic script. We do have a couple of enters in between some of this, and that is because there's a limit on how much you can put into a single line on CopyCon before it runs out So don't find out the hard way, take it from me. Just you want to, I think it's 200 characters, something like that. You're going to need a carriage return. So that's why there is some enter here. Of course, with Visual Basic Script, you're going to have to be careful about when you put your line breaks. I've put them after the colon here. This is a lot of commands butt up against each other. If you looked at this file without these line breaks, it would just be on one huge line. It's kind of like a semicolon in most other languages. So we go through all of those strings. And before I forget, I'm going to delete c:\decoder.vbs so that I don't run into a problem in the demo. And then once we've done that, you can see here we've hit enter, we hit Control-Z, and then enter again. And now it's time to do the same thing except into a file that we call reverse.txt. It's an ASCII text file. No, we're not doing binary injection. We're just typing some ASCII, you know, like any other user would. Of course. I mean, I'm always typing in base64 encoded ASCII into the command prompt. It's actually not that many lines. This particular payload is only 1.2 kilobytes, which is pretty cool because it goes by pretty quick. Of course, we have things slowed down on this duck just to kind of give you a, you know, an idea. You can actually see it. And after we've typed that in, very similar to the other copycon command, enter, Control-Z, and then enter again. And now comes the fun part. This C script is going to allow us to execute that Visual Basic script. And then in this case, the script is decoder.vbs, and it takes two arguments. The first one is our ASCII base64 encoded text file, which is reverse.txt. And then the name of the executable that we want to make it. And we've been obvious here and named it reverse.exe in the root of the C drive. Not very covert. Hit enter, and now we go ahead and execute it. And what I've done here is I've said reverse.exe with a host name and a number. The host name in my case, I'm using my own personal virtual private server where I will have a netcat listener, and we'll show that here in a minute. And then the port, I'm going to choose 8080. And after that, we enter. We type exit and then enter because this is running resident now. There's nothing pops up, nothing shows up, so we can go ahead and close that command prompt. If you really want to get crafty with this, you'll find that other key combos, like over here on the Windows machine, if I hold down Alt and hit space, again, just like the menu key, I get that context menu. I can see that the M is underlined, so that means if I press M on the keyboard, I can start moving it. And then with the arrow keys, I can hold the arrow key down. And of course, Duck would type way faster than I can hold it down. And now, where's my command prompt? It's a little hidden. It's another little way to, if there is actually someone present and you're trying to pull a job where you're like, oh, the PDF for the marketing presentation, totally on my thumb drive. Here, yeah. And then they plug it in and they're like, huh? And a lot of noobs will be like, you know, the non-tech savvy will be like, huh? What's, you know, and they're, oh, weird. Must be on a different thumb drive. Here you go. Anyway. So let me pull that back up and get rid of this. So let's go ahead and use Duck Encoder once more to put this on our machine and then fire up netcat so we can actually listen to the results. All right. So SD card's in here. I'm going to :X to quit. And then just like before, Java, tacjar, Duck Encode. My I is going to be admin.txt, and my O is going to be /media, and then my inject.bin. All right, eject the media, unplug it. All right, and now I'll need to, before I go ahead and launch my payload on this test machine, I need to fire up netcat. We've used netcat before on Hack5, awesome tool. If you're on Linux, you don't have it, apt-get install netcat, boom, it's great. There are versions for Windows as well. Paul, anything on the Mac? I'm sure it is. Well, it's on Linux. You can run it on Mac. So I'm going to go ahead and SSH over into that box. All right. And I'm also running this in screen. So I'll do screen tac X. And we'll do a Control-C and clear. And you can see what I've run here is NC for netcat. TAC L is my listener. TAC K, which says don't quit every time a connection is made and then disconnected. Go ahead and stay resident. And then my port 8080. So there we are on my VPS. nothing is happening because there's no one speaking to it. If you want to send some packets to 8080 right now, I'll see them. Didn't think so. Okay, so got my inject up in on the root of the SD card, ready to go on the Ducky. I'm listening over here. It's time to pwn this Windows box. So go ahead and, as before, plug it into USB drive. And immediately it goes to town. We're pulling up, we're bypassing UAC, and we're injecting the first file. The decoder.vbs only takes just a little bit. File's already copied. And now you can see line by line, again, doing carriage returns. On this one, I think it's every 80 characters or so. And this text file, the base64 encoded ASCII, about to be written to reverse.txt. Done, and then you could just barely see it, but it finished. Maybe I could have just put a string space pause command at the end to kind of keep it on the screen. But suffice it to say, there's nothing more on this Windows machine happening. And if I come back over to my Linux box, there we go. What do I have? dir. I am in Windows /system32. I now have a reverse shell to that machine, and I can do remote administration. Okay, that right there is kind of the basic functionality. Just, here are the tools to start writing some interesting payloads. Of course, the place to go is usbrubberducky.com. That's where you can find the wiki and the forums. You can post your comments, your questions in the forums. Go ahead and publish your payloads. Let us know what you think. Of course, feedback@hack5.org. And stay tuned because you're going to see a lot more great stuff coming out of the firmware. And of course, the updates to the Duck encoder will be over at, I said, usbrubberducky.com. Thank you guys so much, and we look forward to seeing your payloads and hearing your feedback.